Hi class, in this video, I'm going to talk about the last part of chapter 5 and 6, class 4. We will be talking about amortization. Okay, we will be discussing what is amortization loans and how we determine the loan payments based on the interest rates and the loan amount we know for today. Okay, we're gonna create an amortization table to show the required annual payment for each year once we know the beginning balance and the interest rate. We can calculate the annual payment. Also, we will be calculating the principal and interest we're paying for each year. And we repeat the process for every year to set up the table for all the years. Besides calculating the annual payments of the amortization loan one by one, we can also use our financial calculator. We will use the amortization function on the calculator and to see the balance, principal payment, interest payment for each year. Okay, and of course, we will also see the total payment for each year as well. Okay, so we can always come back to the first page after we go over the details. So let's first look at what is amortization. Amortized loans are loans that are repaid in equal amounts over its life on a monthly, quarterly, or annual basis. Okay, so the concept is very much related or similar to annuity. Okay, if you're borrowing a lump sum today and you plan to pay it back in the terms of annuity, meaning you are paying the same amount at the fixed interval for a certain period of time, we will say this is an amortized loan. Okay, for example, if you're borrowing 100,000 today and you plan to pay it back for 5 years, and for each year you're gonna pay the same amount, you're gonna use an ordinary annuity to pay back this loan, then we can say it's an amortized loan. Okay, and this is very usual in our daily life. Probably you have home mortgage, auto loan, business loan, or retirement plans. These are usually amortized loans. Okay, you are usually paying the same amount of money each year or each quarter so that you can pay back the total amount. Okay, but how do we calculate the annual payments? And what are the components of the annual payments? We can construct an amortization table to answer these questions. For example, if there's a homeowner who borrows 100,000 on a mortgage loan, and the loan is to be repaid in 5 equal payments at the end of each of the next 5 years, the lender charges 6% on the balance at the beginning of each year. What is each year's paid interest, principal, and ending balance? Okay, so this is a typical example of amortization loan. You're borrowing 100,000 today. You plan to use ordinary annuity to pay it back at the end of each year for the next 5 years. You're gonna pay exactly the same amount. Okay, it's a 5-year ordinary annuity you will be using to pay back the loan. Okay, and we know that the interest you're gonna be paying is 6% multiplied by the beginning balance of each year. Okay, so you would know the interest you need to pay that year. You also can calculate what is the principal payment you will be paying that year and what is the ending balance you're going to be paid that year. Okay, we'll calculate all of these step by step. But for such question, let's first find out what is the required total annual payment we're going to be paying for the next 5 years. Okay, what is the amount for this ordinary annuity? This is our first task. And we have to determine the payment the homeowner must make each year. Again, we can draw a timeline first. At time 0, we're gaining 100,000. Okay, this is our loan payment that we need to pay back. Okay, we have a positive cash inflow at time 0 worth 100,000, and we're gonna have cash outflows for the next 5 years at the end of each year, and I'm marking payment here at time 1, 2, 3, 4, 5. And the interest rate is 6%. Okay, so by definition, the present value of this ordinary annuity, okay, the present value of all the future 5 payments should be equal to 100,000. Okay, this is the concept of paying this 100,000 back in the next 5 years. The present value of the future payments should be equal to the present value you are getting now, the loan amount. Okay, so if we discount the payment one by one, for the first payment, we use 1 plus 6%, the interest rate, to the power of 1. For the second payment, the discount rate is 1 plus 6% square. For the third payment, it is 1 plus 6% cube. For the fourth payment, it is 1 plus 6% to the power of 4th. In the for the fifth payment, we're dividing it by 1 plus 6% to the power of 5. Okay, we're discount all of the 5 payments to time 0. Okay, we can also show the formula by using the summation sign and indicate that t equals from 1 to 5, and we use the payment divided by 1 plus 6%, which is 1.06 to the power of t. Okay, and then inputs we're gonna do here is that the present value is 100,000 here. Okay, the interest rate I is 6%, and our n is from 1 to 5 in the formula. Okay, however, once we set up the formula, does it look easy to be solved? This formula is solvable, it's doable, but it's very complicated for us to find the payment. Okay, once we set this formula up, it's very much complicated to solve for the payment. Okay, you have to calculate what is 1 over 1.06 plus 1 over 1.6 square plus all these items and divide 100,000 by that amount to get payment. Okay, so the easier way is to use our financial calculator to solve this for this payment, because we know that the present value is 100,000, the cash inflow we're getting today. The interest rate is 6%, so we can just input 6 in the calculator. For n, we can input 5. We have 5 years. For future value, we know we're going to pay off the loan. After 5 years, the balance is going to be 0 in the account. Okay, and we compute for payment. We should get a negative amount, and we should get negative 23739.64. This is the amount you're going to be paying at the end of each year, okay, for 5 years. So it's worth 100,000 today. Okay, let me repeat this process here on our financial calculator. You can also pull your financial calculator out and follow the steps here. Okay, so we know we can input 5 as n. We have 5 years. 6 as I. Interest rate is 6%. Present value is the loan amount, 100,000. PV. Okay, payment is what we will be looking for, and we need to set future value as 0. Okay, meaning we will pay off the loan after 5 years. And let's compute for payment. Okay, we got negative 23739.64. This is what you're going to be paying each year. Okay. One-step conclusion. Therefore, the borrower must pay the lender $23,739.64 per year for the next 5 years. Each payment will consist of two parts: interest payments and repayment of principal. The breakdown is going to be shown on an amortization schedule or amortization table. Okay, so this 23739 is the total amount you're going to be paying for the next 5 years at the end of each year. But for this amount, it consists of two parts. You're paying back the principal, you're also paying for the interest. So out of this 23,000, how much is the interest you're paying for each year and how much is the principal you're paying for each year? We're going to show them in a table called amortization table, and we're going to calculate the amount year by year. Okay, so step 2, let's first find the interest payments in the first year. Okay, from the question, by definition, we know that the interest we'll be paying for each year is the beginning balance in the accounts in each year multiplied by the interest rate. For the first year, we know the beginning balance is at time 0. Okay, and that's going to be the original 100,000 loan. And we're going to use that multiplied by the interest rate 6%. So we know the interest in the first year, INT1, equals 100,000 multiplied by 6%, which is 6,000. Okay, in the beginning of each year, which is today, you actually have 100,000 unpaid in your account. So you have to pay 6,000 interest at the end of the first year. Okay, the interest component is relatively high in the first year, but it declines as the loan balance decreases. Step 3 here. After we find the total payment for each year and the interest payment in the first year, let's find out what is the principal repayments in the first year. Okay, that's going to be the total payment minus the interest payment in the first year. Okay, the total payment as calculated in step 1 is 23,000. The interest we are paying for the first year is 6,000. Okay, so let's take the difference of these two, and the principal payment for the first year should be 17,739.64. Okay, because at the end of the first year, we're paying 23,000 as the total payment, and we know that the part that was paid toward interest is 6,000. So the remaining value must represent the amount of principal repaid. Okay, because there are only two parts for the total payment we're paying each year. So once we take out the interest part, we have the principal part. Okay, step 4, let's find out the ending balance after the first year. Okay, the ending balance at the end of the first year or each year is the beginning balance in that year minus the amount paid towards principal. Okay, so the ending balance, ENDBAL, equals beginning balance, BGBAL, minus the principal payment, PRIN. Okay, so for the first year, we know our beginning balance is 100,000. That's the original loan amount. And in the first year, we know the amount we paid toward principal is 17,739.64, which is calculated in step 3. Okay, this is how much you are paying towards principal in the first year. So we take the difference. We know that the ending loan amount, the ending balance amount in your account at the end of the first year is 82,260.36. Okay, and we can repeat step from 2 to 4 until end of loan to construct an amortization table. Okay, so from step 1, we calculated the total payment for each year for 5 years. From step 2, we know the interest paid in the first year. From step 3, we know the principal we paid in the first year. From step 4, we know the ending balance we have after first year. So if we repeat step 2 to 4, we will know the interest payments, principal payments, and ending balance for year 2, 3, 4, and 5 for all of the years. And then we can construct this amortization table. Okay, let's look at the condition again. Okay, this is the same as the example we list in the first or the last page. Okay, this is an amortization loan again, and this is 100,000 loan in beginning, and we have 6% interest rate. We have 5 years, and again, we can use the financial calculator to calculate that. We have 23,739.64 as our annual payment we need to pay for 5 years, as the ordinary annuity amount we need to pay for 5 years. Okay, so we can first create this second column in this table, which is the total payment we're paying for each year. Okay, we can just put in the same number, 23,000 here for the 5 years. And then we can put in the first column the beginning amount, 100,000 as the beginning amount in the first year. Okay, and then we go to the first row or first year in the third column, which is the interest we're paying for the first year. Okay, do you still remember how we calculate this? How do we calculate the interest we pay in the first year? Right, we just use the beginning amount, 100,000 in the first year, multiplied by 6%. Okay, we use the amount in column 1, multiplied by 6%. 100,000 multiplied by 6%. So we have 6,000 as the interest payment we paid in the first year. Okay, next step, we try to calculate what is the principal repayment for the first year. Okay, how do we get column 4 here for the first year? Right, so we can just use column 2 minus column 3. We just use the total payment we're paying in the first year minus the interest payment we pay for the first year. So we have the principal payment we pay for the first year. Okay, because column 3, interest payment, and column 4, principal payment, should add up to column 2, the total payment. Okay, that's why we can use 2 minus 3 to get 4 here. So the first year principal payment should be 17,000. Okay, next, we try to calculate the amount for the first year in column 5. What is the ending balance for the first year? Okay, so we just use the beginning balance in column 1, 100,000, minus repayment of principal in column 4. Okay, column 1 minus column 4. Beginning amount minus repayment of principal. Okay, so we have this 82,000 as our ending balance. Okay. And then we put this ending balance in the first year, 22,000. Also in column 1 here, okay, as the beginning amount in the second year. Okay, they're both at time 1. It is the end of the first year, but it's also the beginning of the second year. The ending balance in the first year is the same as the beginning amount in the second year. They're both at 10.1 on the timeline. Okay, then we go to second year column 2, total payment. It's the same for every year. Second year column 3, interest. Again, we use the beginning amounts in column 1 here, 82,000 multiplied by 6%. We get 4935.62. So you can see the interest we're paying here is declining because the beginning amount is declining as we pay back more principal. Second year, column 4. How do we get this? Right, we just use the total payment in column 2 minus the interest payment in column 3. So we have the principal payment in column 4 in the second year, okay? We just use the 23,000 total payment minus the 4,900 interest. So we have 18,000 principal paid in the second year. Okay, because the total payment we're paying for each year is the same and the interest amount is declining, so the principal repayments is actually increasing. Okay, the ending balance for the second year. How do we calculate this? Right, it's just the beginning balance, 22,000, minus the repayment of principal, 18,000. So our second year ending balance is 63,456.394. And then we put this number again as also the beginning amount in the third year. Okay, and we calculate interest in the third year by using this beginning amount multiplied by 6%. And then we use the total payment minus the interest we pay for the third year as the principal we pay for the third year. And then we use the beginning amount in the third year minus the principal payment in the third year. So we have ending balance in the third year. And we repeat this process for the fourth year and the fifth year. So we have the whole table, and you can see that the ending balance in the last year is 0, meaning we pay off all the principal. Okay, please try to fill this table on your own. Okay, try to not look at this table and give yourself these conditions and try to construct this table on your own. Besides this step-by-step method, we can also construct this table by using our financial calculator amortization function. Okay, all the steps are listed here on the notes. Let me also show you here on the financial calculator. Okay, if we want to use the calculator to construct the table, step 1 is the same as our step-by-step method. Okay, we always need to get the total amount. Okay, so the first step is always to get this 23,739.64 as the total payment we're paying each year. Okay, you need to input N, I, PV, and FV to compute for payment to get this amount. Okay, after you get this number here, then we press second amortization. Okay, this is the same button as PV, but you can see that it shows AMORT. Okay, second amortization. We come to our amortization table in the calculator. We see that P1 equals 1. P1 means starting period. Okay, we start from the first period. In this case, we start from the first year. And then we press down button. We go to P2. Okay, this is ending period. P2 is ending period, and it's by default 1, meaning the first period. Okay, so we begin from the first period and at the first period. So all the values we're going to see later is for the first period. In our case, all the values we're going to see later is for the first year. Okay, so let me just press down button again. Now I see BAL. Okay, this is the ending balance. Excuse me for a second. Okay, so to make sure we have the right inputs on the calculator, let's repeat the first step again. Okay, let me input 5. Let me first press second quit, okay, to quit the amortization table. Let's repeat the first step. Let me press 5 and, okay, 6 as interest rate, 100,000 as PV, 0 as future value. Compute for payment. Okay, this is how we get 23739.64 as the total annual payment for each year. Let's go to second amortization table. Again, let's keep P1 as 1. Beginning period is first year. Down button. Let's keep P2 as 1. The ending period is also first year. And let me press down button again. Okay, so here it shows us the balance, the ending balance in the first year. Okay, the calculator automatically calculates it. So we can see it's the same amount as in the table here. Okay, the ending balance 82260 is the same as what we calculated by hand. And I press down button again. We see PRN. This is the principal payment in the first year, 17739.64. Again, the same amount as how we calculate by hand. Let me press down button again. So we go to INT. We see that the first year interest payment is 6,000, same as what we calculated. Okay, let me press down button again. So I come back to P1. Okay, now my P1 and P2 are both first year. And you can always write it down, what you have already seen here on the calculator. Okay, ending balance, BAL, principal payment, PRN, interest payments, INT, are all shown here. Okay, now we want to see the values in the second year. Okay, we can press compute. Okay, as long as we press compute, P1 becomes 2. Meaning the beginning period is the second period. In our case here, we start from the second year. Okay, press down button. P2 automatically becomes 2 as well. So now all the values are going to be for the second year. I press down button. We can see that the ending balance here becomes 63456. Okay, same as what's in the table. And I press down button again. We see 18804 as the principal payment for the second year, same as what we calculated in the table. Press down button. We see interest payment in the second year, 4935.62. Okay, we can write it down as the interest payment for the second year. Okay, what if we want to know the third year? We just press down button, we press compute again. Every time we press compute, P1 and P2 increase by 1 unit at the same time. Okay, so we increase to year 3. And we can see the ending balance is the same as what we calculated in the table. Principal payments 19932, interest payment 3807. Okay, down button, compute again. Now we can see all the values for year 4. Compute again, P1, P2 goes to 5. We can see that the ending balance is almost 0. Okay, we pay off all the loan in the last year. Principal payment 22395, highest among the 5 years. Interest payment lowest among the 5 years, 1343. Okay? After repeating these steps and get values for every period, and you can write it down to construct the table. Quit and clear TVM. Okay, so we can always press second quit and second clear TVM to clear all the numbers in the amortization table and the TVM table. Okay, I don't want to clear them here because I want to show you that P1 and P2, they can increase at the same time by pressing compute. Okay, but we can also enter the actual number. Okay, as you can see on the screen here, there is an enter sign here telling you that you can actually enter the P1, P2 values. Again, P1, as we can see on the notes here, P1 is starting period, P2 is ending period. So if we want year 1 or period 1 payment, we set P1 equals P2, P2 equals 1. If we want period 2 or year 2 payment, we set P1 equals P2 equals 2. By pressing compute, it can make P1, P2 increase by 1 at the same time, going to the next period. You can also enter numbers for P1 and P2, but make sure you change them both to a same period number. If you enter different numbers for P1 and P2, say if you put P1 as 1, P2 as 2, you will get total payments from period 1 to period 2, which we usually do not use. Also, second clear work can bring you back to P1 equals to P2 equals 1. Okay, so now I'm at P1 equals to P2 equals 5. But if I want to get back to P1 equals to P2 equals 1, if I want to go back to the first year, you can input P1 as 1, enter, down button, P2, 1, enter, down button, okay? Or you can press second clear work. Let me try press second, okay, clear work. You see, P1, P2, they come back to 1 again. And you can see the ending balance, principal payment, interest payment again in the first year. Okay, if you want to go to the second year, you can press compute, or you can press second, enter. So your P1 is 2. For P2, let me also press, see, this is error because P1 is 2, P2 is also 2 now. Okay, let me input all those numbers again to calculate the payments. Compute for payment. Second amortization table. Okay, let me change P2 also as 2, enter. Now my P1, P2 are both 2. This time is if we press down button, there's no error anymore because our beginning balance and second balance are in the same year. Okay. Excuse me, beginning period and ending period are in the same year. So all the values are gonna be for the second year. Okay, alternatively, you can make your P1 to 2, P2 to 3. So all the amount is gonna be for 2 years, okay, including the second year and the third year. Okay, but we usually do not do so. We just increase both of them to 3, so we know the amount for the third year. Okay, if we want to know the amount, for example, in the 5th year, we just enter P1 as 5, enter, down button, P2 as 5, enter. Okay, so P1 and P2 are both 5 right now, and we can press down button to see the values. We can also change it back to 1 by pressing 1, enter for P1, down button, 1, enter for P2 as well, down button, all the values. Okay, please try to practice with your financial calculator to construct this amortization table for this example. And also you can try to just use our step-by-step method to manually calculate this table. Okay, try the 2 different ways. All right, by using our financial calculator, okay, we can construct the same table here because the financial calculator shows us the amount in column 3, 4, and 5, INT, PRI, and BAL. Okay. One thing to note here is that we actually have constant payments. Okay, all the payments in each year are the same by definition. However, the interest payments we're paying for each year is declining. Okay, the total payment is the same. It consists of the 2 parts, interest payment and principal payment. But the upper part here showing on the graph is interest payment. It is declining because the beginning balance is declining. Okay, and And because that interest is just the beginning balance multiplied by the interest rate. Okay, if the beginning balance is declining and the interest rate stays the same, the interest payment each year is declining. So the rest part of the payment, which is principal payment, is increasing for each year. Okay, let's look at another example here. Practice. Consider we have a 30,000 car loan with these terms. 6.75% APR for 16 months. Okay, still remember what is APR? Annualized percentage rate. It is the same as stated rate, quoted rate, or nominal rate, INOM. Okay, but this time we're not having compounding periods once per year. Okay, we have monthly rate here. Okay, we have 12 compounding periods per year. We're doing monthly compounding here. How should we solve this question? Okay, maybe you can challenge yourself. Before looking at the answers here, please try to solve the question yourself. Okay, try to think about what is the nominal rate and what is the periodic rate for this question, and what is the rate you are going to be using to calculate the annuity or the payments for this loan. Okay, you have 30,000 as the PV, as the original loan amount. Okay, and you have 16 months to pay back the loan. What is the interest rate for each month? How do you calculate the monthly payment? Okay, try to calculate the monthly payment by using your financial calculator, TVM worksheet, and then construct the amortization table by using the amortization function in the calculator. Okay, I'll give you some time. Please, I'll finish this video, so you can also pause watching the video. Okay, try to get your calculator out, get a pen, pencil out, try to solve for the monthly interest rate for this question, also the monthly payments, and use the amortization function to construct the amortization table. Okay, once you finish working on this question, you can read the solutions in the notes. Alternatively, you can watch our next video. Okay, I'm gonna talk about the solution for this practice problem in the next video.